Well, hi folks, meteorologist Michael Wilhite here with SouthernIndianaWeather.com. Thanks for logging on here to the preliminary winter forecast for the 2017-2018 year. It is September the 29th, 2017. As I am issuing this, I forecast primarily for Southern Indiana, but I know many of you who subscribe to me on YouTube are from all over the United States, and if you're just searching YouTube for the winter forecast, you may find this anyway. I'm going to cover all over the United States, but with a primary focus as we get into more some of the specifics on Southern Indiana a little bit later in the forecast. But I will cover things that will be applicable to the entire United States, the lower 48, so depending on where you are there. As I try to do every September, by the end of September I issue a preliminary one. Then I have a final winter forecast later on in case some things have changed. That final winter forecast will come out in December. So let's get started with all of this. Let's dive right into the data here. This will be a pretty detailed video. If you're interested in more of just a quick synopsis of it, head on over to my website, SouthernIndianaWeather.com. From there, you'll be able to find the preliminary winter forecast. You can read a text and a lot of the images that are here to go along with it. And, depending on how long this discussion ends up going, you may be able to read it quicker or not, but that's there for you. Available. Let's start out with La Niña. This is where we are at right now. Now, we're going to talk about, first off, about several things. We're going to talk about the ocean temperatures, then we're going to get into the analogs, and then we'll get into some of the modeling after that and start talking about my thoughts, wrapping everything up there. At the end, that's kind of where we're going here. But first thing we need to look at is the ocean temperatures. Why the ocean temperatures? Well, because the ocean is a great driving mechanism for our weather. The ocean holds heat much longer than the surface temperatures do, and so they tend to drive weather patterns. We have three out in the ocean in the that we really look at: La Niña, El Nino, or is it neutral state, which we often call La Nada. Right now we're headed into a La Niña. We are not there officially yet. Officially, to be a La Niña, you have to have 3 consecutive months with values below a ½ degree Celsius in the negative, and so that's what this blue line that I've placed here on. This represents your La Niña borderline. This represents your El Nino. Everything in between is what we would call neutral, or just the La Nada sort of things with it. You can see here we have definitely noticed a trend. Here was the beginning of July. We had warm waters, but we are trending down here, and we have been below the 0 degree line ever since about mid-August here, and it's been sort of an up and down pattern here, and this is very typical. La Niña is yet to take hold, but it is forecast to take hold. In fact, the National Weather Service has us under a La Niña watch. That means they've given us a 55% chance of seeing a La Niña develop a little bit later on in the year. What does the modeling say? Well, if we just look at some of the various modelings, the CFS, which is the American model here, certainly predicting a La Niña for us as we go into here. Now, it's very aggressive and it gives us a very strong La Niña. It is one of the only models doing that. Some of the other models make it a little bit more moderate. This is the POAMA model. This is the Australian Bureau of Meteorology, their model. They use, by the way, a little different status for La Niña. We use a ½ degree. They use 0.8 of a degree in the negative as their threshold for La Niña. But I put R's on here to keep consistent. And you notice their forecast, all these individual lines are different forecast members, but the mean of all of those particular models is what this green line here is with the green dots. And that gives you, yes, a weak La Niña, rather, as you go through it. You can see that's a pretty big difference here compared to the moderate to strong El Nino that are the American models are predicting. If you look at just some of the others from around the world too, you can see all of these different models and pretty much everything here. December, January, February is on this line right here. That's what DJF is. And you can see most of the models, not all, but most of the models are saying we go into a La Niña. That blue one right there is your CFS, so you can see how extreme that is compared to the others. But it looks reasonable to assume right now that we are going to go into a La Niña. Now, we may not necessarily go into an exact La Niña state. It may just be a La Niña-like if it never gets characterized, but it's certainly going to have the effect whether it's given that designation or not. We are heading into a La Niña-like winter. Now, of course, you may realize, you may think back to the previous winter forecast from last year and say, well, weren't we supposed to go in a La Niña last year? And indeed we were, and things completely turned around. So things look a little bit different. I don't think that we're going to see that big turnaround to go away from La Nina this year. I think it's starting to take hold, whereas it wasn't last year. But we'll just have to see. And of course, that's why I issue a final winter forecast a couple of months down the road. That'll come out on December 1. It's 9/29 as I'm recording this. I always give that for just for the sake of things change, where we can get a final one in there. What in the world is La Nina? Well, La Nina is an abnormal cooling of waters out here in the equatorial Pacific Ocean, from here off the coast of South America over here towards Australia, and the islands above Australia over here, Indonesia and sorts. It's basically this blue waters as you see here. Again, that's cooling of the waters. Where everything that you see in the red and the orange shades is warmer than normal, everything as you see in the blue shades is cooler than normal. And that gives you an idea that La Nina is really starting to take hold there. Now, what does it matter? Why in the world do we need a La Nina? Why do we need to understand this? Because La Ninas have a very direct effect on us. Now, over the summertime, they don't typically have that much of an effect, but as we get into the wintertime, they can have a real effect. A typical La Nina winter makes it very dry in the southern portion of the states. It also makes it very warm down here. It sort of contains the cold out to our north, and it makes sort of a wet spot here right over the Ohio Valley, and it also makes another wet spot as you come in off of the Pacific Northwest, because La Ninas tend to amplify the Pacific jet. Now, how amplified that gets will help determine how warm we get, and we'll talk about that here in a little bit. The other thing that we need to talk about a little bit is the analogs. And so an analog is basically a year that has similar SSTs, sea surface temperatures, in both the Pacific and the Atlantic Ocean. So I'm looking for things specifically like La Nina and El Nino, but I'm looking also at the PDO, the AMO, and some of the other things that you may or may not understand. But I'm looking at going back to that map of the ocean temperatures. I am looking at things that have very, very similar conditions, and then essentially from there looking at years in the past so that I can say, well, what was the weather like in these years past under these? And so these are the analogs that I have come up with this year: 50, 51, 54, 56, 64, 71, 74, 2000, 2007, 08, 10, 11, and 12. These were the years that had a similar weak La Nina in place, and some of the ocean temperatures around. They were not perfect matches compared to this year, but close enough that I wanted to take a look at. Now, if you combine those years all together and come up with what the average temperature was, it gives you a map like this. And so everything that you see on this side of the color bar is above normal temperatures. Everything that you see on this side is below normal. And so what you notice is a very clear distinction, and that looks very similar to that typical La Nina winter that I showed you earlier, where the cold is sort of confined out to the northern portions of the states, whereas you have the above normal temperatures down here. Here we are in southern Indiana, where I primarily forecast for. These would give us pretty much an average winter, but you notice how close we are here to the above normal. And so this would essentially, I believe, give us a near average to slightly above average in the temperature department. The core of the cold sort of way off here in the northern Great Plains. As far as precipitation wise, there is that active storm track right through the Ohio Valley and up the Tennessee Valley and up Appalachia here. And you can see that's your above normal precipitation, well below normal here along the southern coast and way down in Texas and all the way up into here. There's some above normal streak here in your Pacific Northwest, very similar to what we saw in a typical La Nina winter. So now what we want to do then is take a look and say, well, how does our analogs that I've analyzed here and said this is what I think looks like the best that I can come up with as far as things in the past, how does it compare to what the climate modeling is showing us, the seasonal modeling? Well, all of these are what I'm going to go through here. On the web page, I gave you just one to look at, but in the video I promised more, and I'm going to go through all 7, I believe. 1, 2, 3, 4, 5, 6, 7. Yeah, I'm going to go through 7 different models here with you. There's a lot more that we can look at, but this just gives you an idea. So, for example here, examining how close these models are to the analogs will tell you how much confidence you can have in this forecast. Well, let's look at these things. It's very interesting. A lot more agreement in the modeling and the analogs this year. There was not good agreement at all in that last year, all right? So the CFS is the American model, and this is predicting a very warm very warm west and most of the country, but you notice there's some cold right up here into the plains coming down. And well, it is not a perfect match over here, but you get that there's some similar ideas, certainly, with that. Some exceptions, but overall some similar ideas here. If you look at the precipitation, very similar here. You have some wet patches over here towards the Pacific Northwest, dry over here in California, and then you've got that active track right through the Ohio Valley. So the CFS model doing a pretty good job comparing with the analogs. If we look at the CANSIPS is the Canadian model, the Canadians seasonal model here, and you can see there it is doing a pretty good job of forecasting the warmth over parts of the country. It doesn't really capture the below normal, but up here in the places where it is below normal in the analogs, it's at least normal, so the hints of it is there. If we take a look at precipitation, it does miss the Ohio Valley here, but it does hit up here, into the northwest, and hints of some dry down here in the southeast. So it has some hints with it. NMME is a toasty model. It is almost always a toasty model. It has a very warm bias, and it's been wrong far more times than it's been right. I don't really like this model, but again, it is capturing warmth. But it is at least seeing hints of near normal here. That's not the below normal that you see on the analogs here, but it's a little bit closer than it could be. For precipitation-wise, it tends to do better usually than it does with forecasting temperatures, and it does capture that hints here of an active storm track through the Ohio Valley in the northwest, and then dry here in the southeast. So again, that's some hints on this. If we look at the UK Met GPC, this is their seasonal model for the UK Bureau of Meteorology. Everything that you see sort of in these yellowy, goldy, and red colors, this is above normal. The greens are the below normal for them. And look at that. Look how similar this is to the analogs. There's your core of your cold, and with the UK Met, there it is all up into there. And then here is your warmth back up into here. Again, not a perfect match, but similar. If we take a look then at precipitation, everything in the green is the above normal, whereas you get into these blues and the reds here, that's where you get into the blues are above normal. If you get into the reds and the yellows, that's whenever you get into the below normal. So there's hints of some above normal track here through the Ohio Valley, some hints of some dryness into the south there around Florida and up into the plains. Not a perfect match for the model, but it is getting the idea down. The CCSM4, well, that model did actually fairly good last year. It's a pretty recently new model, and take a look at what it's showing there is your cold. This is an American model, by the way, I believe. Yeah, it is. It's from NCAR, National Committee on Atmospheric Research, Corporation for Atmospheric Research, rather, I believe. Anyway, there's the core of your cold up there, and you see it sneaking down into the northern tier of the plains, warm up in here. So that's a very similar precipitation-wise. Look at that. Active storm track through the Ohio Valley, very wet northwest, very similar to what we see with the analogs, very dry out into the west, and hints of dryness down here in the southern tier of the states. That's doing very well. This forecast model actually did pretty good last year overall, and so that's a good thing to be able to see that with this. And then if we take a look at the IRI, which is a conglomeration of many models and its issues on probability. It's the only one, by the way, saying for the Ohio Valley that there will be cold. It's the only one that I can find, folks. But you can see there it is. There's some of your cold. A little bit different positioning than what you see in the analogs, except for up in here. You see that's right. It does have this portion up here, right? It extends it a little further south. Warmth there into the deep south, similar to what we see here. It has at least some similar ideas. Precipitation-wise, look, there's some green in the Ohio Valley and the northwest there. Again, that active storm tracks in those spots, dry in the deep south. Very similar to the modeling here. And then finally, we'll look at the JAMSTAC. The JAMSTAC is the Japanese Bureau of Meteorology's model, their seasonal model, and it has been very reliable most years. In the past, it has a long track record of being pretty reliable. Look what its latest run here from September is showing. Here's your warmth, there's your coolness, and look how close that is to the analog. That is almost a perfect match to the analog. Not quite, but dang, that's really good. Now look what it does on precipitation. It's a little bit dry here in the northwest, but you see some hints of dryness right on the coast in the analogs. Look at this. There's some green sort of offset. There that is. There's the dry out west and the deep south there too. And look right here through the Ohio Valley. Active storm track. This is the JAMSTAC, very, very close to the analog. So all that to say, that gives us a higher degree, I think, of confidence than what we would see in normal years for a preliminary winter forecast. I've given my winter forecast about a 50% confidence at this point because the models are various models, not just one, but many of them, in very good agreement with the analog package that I've come up with, and that gives us fairly good high degree of confidence. And if that continues over the next couple of months, by the time I release my final winter forecast on December the 1st, well, we may be able to have an even higher confidence forecast. That's pretty cool. Talk about snow. That's what everyone wants to do. Folks, if you're watching this outside of southern Indiana, realize I am southernindianaweather.com. I forecast primarily for southern Indiana. Let me just talk briefly about southern Indiana first. I will show you some snow thoughts for the nation here in a minute. Hang on. But for those of you in southern Indiana, if we're looking at this from Evansville, Indiana, our climate normal is about 12.1 inches of snow. What I've done is I've taken all of those analog years and I've plotted the snow that we saw in that season. And the blue line here is your climatological normal. And what you do is you see 6 years we're below normal, 5 years above normal, and 1 year near normal. So you sort of run the whole gamut. So even though it's probably going to be a slightly above average winter in the temperature department, the way things are looking, that doesn't mean that you don't get any snow. In fact, you've had some big snows. In winters similar to this, look at this, there's a 26-incher, an 18, 19, 17, 15. Those are some pretty decent winters for snow totals. There's one that was average, but I caution you, even you see those high totals, we've also had winters with a ½ inch of snow. Only 7 inches, another 7-inch, a 2.6. So they really run the whole gamut. All that to say, these big winters came where you had pretty much one big winter storm roll through, and otherwise you wouldn't have nearly that amount. La Niña winters do typically tend to make less snow for us. So you keep that in mind. It would not surprise me at all to see a below average snowfall year for us here in southern Indiana and over much of the country for that matter because of La Niña. But that is not to say that we can't have snow, even though we may be below normal. Certainly we look back in the analogs and we see there's potential here. If we could get everything to line up just right, maybe we could get that. All right. So here's my winter forecast then, sort of taking a look at things. If we go in the temperature department, here's what I'm thinking. Again, as of the September the 29th here, as I'm recording this, forecast confidence about 50%. There's your above normal, stretching all the way up here into parts of New England, down through all of southern Indiana, even parts of central Indiana and down. Some well above normal temperatures in the south, and you're below normal sort of confined out west, and you're well below normal up here to the east. Equal chances sort of there in the middle with that. Again, this is sort of taking a blend of the analogs and the models and just some understanding of meteorology and what La Niñas typically bring us. Looking at precipitation, again, I think you're going to see some well above normals right here through the Ohio Valley. I do think you're going to be above normal here in Washington and sort of extending over for a good while. Well below normal out here. It's well to the west and below normal here in the deep south. I almost added a well above normal here in the Washington area, but I did not yet. I might in the final winter forecast if some of the data comes back in still indicating that. But that's still a big if to me right now. As far as your snow chances, well, this is what I think. Most of the country going to be below normal because of La Niña again. Above normals, here's where I think you're going to have, and it's going to be sort of confined up to there. Again, these maps may be adjusted a little bit as we get towards the final forecast, but this is my thinking, folks, as of right now. Dialing in here a little bit to southern Indiana for the southern Indiana weather area that I cover here. Again, here's some seasonal averages for some various towns here in southern Indiana. Here's what I think for us, folks. Above normal temps are likely. Yes, I do think it's going to be cooler than last year. Last year was an extremely toasty winter. It'll be very hard to repeat that. It could happen again, but I don't think it's going to be quite as warm as the past two seasons. Again, I think we're going to be on the above normal side when it's all said and done. That does not mean that you can't get cold air invasions. You could get some cold air events come in, but again, I think those are going to be fewer when you have a La Niña winter. We'll have above normal rain most likely with that active storm track, but that doesn't necessarily translate to snow because you have to have a cold source with it. And cold sources are going to be very hard to find for us in the Ohio Valley this winter. I really believe that because of La Niña. And typically whenever you have a La Niña, you can bet on that more than you can on the cold, folks. So I think below normal snowfall, if we can get 50 to 75% of average, that would be awesome. Last year we only got less than 25% of average here in southern Indiana, and it was a really sucky winter for you snow lovers out there. I think it'll be a little bit better, but I don't think it's going to be just a bang-up winter unless we can just get a mega snowstorm and everything. All the stars lining up perfectly where we can get that one perfect storm. It could happen. It could happen in any winter no matter what, but it's not favored this year, folks. Well, let's talk about risks there real quick then. What could bust this forecast? Well, first off, how fast does La Nina develop and strengthen? It's not developed yet. It's still developing. How strong is it going to get? Well, I showed you some of the models. Most of the models take it in the weak side, but does it go moderate or does it go even a strong La Nina? The stronger it gets, the warmer the country is going to get. And so if you're watching this from, Washington, Montana, the Dakotas, Minnesota, Wisconsin, places up in there where you're thinking that you're going to have a cooler than normal winter at, a weak La Nina, yes, but if it gets a stronger La Nina, you could end up having that cool erode from you very easily with this. So that's a thing that could bust this. If La Nina doesn't develop and we go back to neutral conditions, the country could be cooler. So there's a risk with that. Do you think La Nina is probably a La Nina-like state, at least, is going to develop, though, folks? What about the position of the southeast ridge? La Ninas tend to promote a ridge of high pressure into the southeast corner of the United States. Where's that set up? Is that set up closer towards Florida or closer towards the Tennessee Valley? Where that sets up is going to be key in determining who gets the extent of the warmth this winter. As far as that, how strong is it? Where does it set up? And then lastly, last year the reason we got so toasty is because La Nina never really developed, and she went opposite of that, and the Pacific jet went nuts, and we had this Pacific jet extension that was abnormally fast coming in off the coast of the Northwest. And what that did is it just pumped mild Pacific air into all of the country rather than getting the cold source from Canada. The jet stream was not amplified, and as a result of that, the whole coast country for the most part was toasty. Do we see that again this year? Well, there's a real possibility of that. So again, there are some risks. If I were going to bet on anything, folks, I would not bet on cooler risks. I'd bet on warmer risks, the way things are looking this winter. Again, that doesn't mean that you won't see snow, folks. I just don't think it's going to be a bang-up winter for most folks, especially here in southern Indiana and really for most of the nation out there. It could be a pretty disappointing winter for you snow lovers. On the bright side, I think it's going to be better than last winter, and it was hard. It's hard not to be better than last winter for a snow lover. So you can take that, and maybe we'll get some. Look for the final winter forecast out here, folks, on December the 1st. Leave a comment. Got a question? Leave a comment below in this video on YouTube. I'll answer them as quickly as I can. I'm meteorologist Michael Wilhite. Thanks for watching. I know this is a little long, but now you know the details of the forecast. Again, check back here on December the 1st for a more detailed final outlook.